Hi, I'm Charlie with Precision Matthews, but today you can call me Upton Sinclair, the way I'm talking about oil. We stock a gear oil, a whey oil, and a water-soluble coolant, and knowing which bottle is for what is vital to keeping your machines in top condition. Let's get started. The top oil question that we get is, what is the difference between the ISO 68 Gearbox oil and the ISO 68 whey oil? Does one have more tannin or a heavier body? How's the nose? Which pairs best with the tuna steak on the menu? Well, they have the same viscosity, but the whey oil on the right here is just generally stickier, for lack of a better term. It stays where you put it longer, runs less, and is ideal for any of the bare metal sliding surfaces on your machine tools. The Gearbox oil will be used in just about any gearbox. That includes a headstock, threading gearbox, and apron. And the whey oil is used basically anywhere else.
Huh?
Here's the barely scientific test I devised to illustrate the difference between the two oils. I dripped an equal volume of each down a metal sheet to see how they run. The whey oil is on the left, and you can see that the drop at the bottom is smaller because it has more of the oil left behind. When you're lubricating the slideways, I think I'd rather have more of the oil on the ways and less dripped down into the chip tray. So that's simple enough, but what about the other fluid we sell? We stock this water-soluble coolant. It's meant to be diluted between 5 and 8%, and 1 quart in 5 gallons of water will get you about a 5% concentration. We highly recommend mixing in a bucket before you add it to the coolant tank. Yell at me in the comments for using the hose instead of being fancy with jugs of distilled water. You don't even need a stick to mix it if you squirt it hard enough into the bucket. Just make sure you're familiar with how the hose nozzle turns off. It's clockwise. Wait, no, the other clockwise.
Let me get a towel.
You can check your mix with the refractometer. These are cheap and easy to use, so there's no excuse not to have one. If you messed up and put more water than you intended, something I would never do, you need to add more coolant concentrate, then stir it up with your ultra-precision machinist's scrap of electrical conduit. I aimed for 6% concentration, and what's in the bucket is right on. Can't speak for what's on the floor. People often ask about rust concerns with water-based coolant, so I devised this experiment that is somehow even less scientific than the oil drips from earlier. I grabbed this random vise from our tool room, and I'm going to try and get it to rust. I cleaned off the bottom half here with acetone to get it down to bare metal. The top half I left with whatever unholy coating of WD-40, Tap Magic, gas station coffee, and tobacco spit that was already on there. I didn't add any protectant for this, just what was already present. In the middle, I dropped a 6% dilution of our coolant, top and bottom, so exactly how you would use it in a flood coolant system. A control drop of plain old water on the left, and coolant concentrate straight from the bottle on the right. Here's the same vise 24 hours later. In the bottom left, we confirmed that regular water left on clean bare metal causes rust. Groundbreaking research here. The top left, we see that the regular wash of cutting oil and spilled white monster is almost enough to keep the drop of water from rusting, but it got a little spot. In the center and on the right, we see that the coolant didn't stain or rust regardless of whether it was concentrated or diluted, with the same results on the protected metal on the top and the clean bare metal on the bottom. When I wipe the coolant drops away, there's no evidence they were ever there in the first place. Could rust be caused by improperly diluted or improperly mixed coolant? Sure. Does this experiment in our nice dry shop hold true if we tried it again in the Everglades in August? No, but generally this coolant can be used without worrying about rust or corrosion. So there you have it. You don't have to be a chemical engineer to understand using the right oil in the right situation. And now you know enough to keep your machines running well. As always, if you have any questions, drop them in the comments or give our tech team a call. Until next time, thanks for watching.